job as a draftsman with a trust building company. Initially, it just started in drafting. Since I knew the background of building, I found that to be easy. That was the next challenge or the next step into understanding the actual engineering behind it. I went back to school, and then as I was working and I went back to school, I considered going back into getting a civil engineering degree. I ended up getting a job with another civil engineering office. That one we did both residential and commercial, the roof structures and the floor structures for engineered lumber, and designing it using the company software. We used to build out the roofs and the floors. Sometimes they were flat. Most of them were A-frame. But that's where I started to understand the mechanics behind it. And I really enjoyed that I really enjoyed just understanding certain mechanical things that occur in nature, or like when you build and all that, personally. But then after working in it for a couple years, it's a bit of a stale environment. I don't know if anyone's ever worked in that. And it's nice kind of when you get different new projects, because then you get challenged and you kind of, for example, like on a commercial building or at least that I worked on, they're irregular. They're not just like a box. So when you have to put roof systems on that, or even floor systems, and they're cantilevered, or they have a lot of different mechanical challenges, that becomes fun, because then you understand like the different things that you can try to do, but not everything is doable. And that's where you get more kind of intimate knowledge of like not everything is possible, but you run it through your software, and if it works, then it works.
What software are you using?
So the ones that we used, they were company specific. There was a smaller company that I started out with initially. It was called Hanson. The engineer was also the engineer on record and stamp, and he actually created the software. And it was just it's for the most part, like if you know about mathematics, and you can create certain softwares that are kind of basic. The other company was a Weyerhaeuser, I-Level Truss Joist. It was a subsidiary of Weyerhaeuser, and that one was a larger software because we dealt with certain commercial stuff. But the software essentially comes down to, when it comes to roof, if it's not engineered lumber, and if it's like your stamp plates that they use on 2x4s or 2x6s for roof structures, the software deals with two things. It deals with the actual, where they run tests through the actual lumber. This is what they do for those that don't know, for structural engineering. Yeah, for any member that's carrying a load or is susceptible to a load, like through wind or through seismic load, what they do is they cross-cut the member, and mathematically they put a stress on it to see how it will do according to any stress from, like, say, a hurricane or earthquake. And then from that, then they know what are its minimum and maximum, and then it'll either pass something or it won't. Like the C to D variation that they did, that specifically, that's what I was going to say with beaches. Anywhere along the coast, you can always assume the worst case scenario, because the D goes to, I think it's like 175 miles, sustained winds for 3 minutes or something like that. And so just for future reference for anyone that wants to do along the coast, they'll always look at the worst case. Because here,
is there more cost for the draftsman or the architect to make it up to 175?
No, not at all.
So why don't they only give it to you for 160 or 150? Like, what's the point?
So for example, where I live in the inland, if you look at like a IBC book, International Building Code book, they will have, based off of, like, say, the outline of the U.S. or Florida specifically, it shows like the outlines on the coast, and then from there, there's like gradients that go from the outside in with the wind speed. And so the C rating must be at, like, say, I don't know what it is exactly. It'll show in reference, but it probably starts like at 15 miles or something like that, inland. And that's probably why they did that, because most people are not building along the actual water line. Most are like in somewhere.
But wouldn't a builder want to have it as strong as possible?
You would think, but see, that's where, so it still comes down to, at least for when we would build the trusses, whether the roof or floor, it's still a business. So what you're trying to do, and this is what, it goes in all manufacturing when you start looking at whether it's cars, phones, whatever, what they try to, all manufacturers, what they do is they rate to the minimal amount acceptable. So, because that also bears in costs. In, like, for example, for wood specifically, you have the different grades. And if you have select one, that's like the best in terms of strength and grade, that will cost you the most.
Gotcha.
So there's no point in getting the most expensive, especially if you're trying to save on your
the
build
build.
costs. There's no point in getting the best, even though, okay, it can withstand maybe King Kong coming along. I didn't mean that to rhyme, but nonetheless, it can withstand that, but there's no point in that because you're just spending a lot of excess.
Gotcha.
And so so I was to go back in terms of the engineering, what we did, or at least what the truss manufacturers do, they do two things. They look for the wood grade. When they cross cut, they see what it can withstand in terms of strength, and the other one is for plates. And the plates are what hold it all together. And the plates will be different sizes. So that's when when building your own software, that's what you would do. And you have to have like a intimate knowledge of the structural components of those factors. And then this warehouser, they got into engineered lumber. They still exist, and they're like one of the larger throughout North America. And